is a 45, 45, 90. Okay? Now, we've learned, now, it's been a little bit, because I know we just got back from Christmas, but we've learned that the measurements of the sides of a triangle have a direct relation to the angles that are opposite to them, right? Correct? So if you have two angles that are the same, two of the sides are also going to be the same. Does that make sense? Okay? So in a 45, 45, 90, the sides opposite those 45s, now this is the basic pattern that you're going to follow. Okay? We've been doing similar figures, right? Where we set up ratios and we set up proportions to solve for missing sides, and we have two similar figures, correct? So if I give you another 45, 45, 90, but the measurements are different, you're going to use this to set up your proportion, okay? Any 45, 45, 90 triangle is similar to this one right here, okay? Now, so you just have to memorize the legs in a 45, 45, 90. The legs are each 1, and the hypotenuse is square root of 2. 1, 1, square root of 2. If you tried Pythagorean theorem, if you didn't know the hypotenuse, you do 1 squared plus 1 squared equals c squared, you get square root of 2. Okay, we leave it in exact form. So 45, 45, 90, the easiest way to remember that is your angles are the same, so you have two legs that are the same. Okay? So 1, 1, square root of 2. In a 30, 60, 90, you remember, now I'm trying to give you ways to help you remember what the sides lengths are, okay? 30, 60, 90, 30 is the small angle, 60 is the big angle, okay? So opposite the 30 is 1, opposite the 60 is square root of 3. If you actually calculated that, it would be bigger than 1. And then opposite the right angle is 2. So it's 1, 2 square root of 3. Okay? In both of these, I'm going to tell you another little number pattern. In both of these, the hypotenuse, it's got a 2 involved in it. Okay? In the 45, 45, 90, the hypotenuse is square root of 2. In 30, 60, 90, the hypotenuse is 2. So if you get confused on where the 2 goes, it goes on the hypotenuse. Okay? So you just have to memorize these patterns because you're going to use that to solve all of the other problems. Okay? You're going to use this to set up your proportions because you can compare these to any other similar triangle, any other 30, 60, 90. So if I gave you another 30, 60, 90 triangle and I gave you only one of the sides, okay, if I give you 2 of them, you could use Pythagorean theorem to find the third one. You don't need this. But if I only give you 1 and ask you to find a different one, then you have to use this to set up your proportion, to set up your corresponding parts. Okay? So let's look at an example. So let's go to number 1. Which type of triangle is this? 30, 60, 90 or 45, 45, 90? 45, 45, 90. They don't have to give you both 45-degree angles. They only need to give you one. Okay? So that's a 45, 45, 90. Okay? If I didn't have the special pattern for 45, 45, 90 to compare it to, this wouldn't be enough information for me to figure out what either X or Y is. You can't use Pythagorean theorem when you only have one of the 3. You need at least 2. Okay? And so what we do is we basically say, well, let's set up a similar triangle and use proportions to find that missing piece. Okay? And so instead of drawing a whole separate triangle, let's just pretend that this is our basic 45, 45, 90. Okay? These are my legs, right? So if I go and I fill in these values, then this would be 1, this would be 1, and what would this be? 1, 1 square root of 2. Okay? That does not mean that x is the square root of 2. Let me draw the triangle separate before I jump to this shortcut. So here's the other one. So we know 1, 1 square root of 2. Because that's the other 45, 45, 90. The basic one. Right? And these two are similar because they're the same. All the angles are the same. Right? Correct?
Yeah.
Everybody follow me? I know it's early. So we can set up our proportion now using the corresponding parts. Okay? So we're trying to figure out what this is. This is what we don't know. So we say x over square root of 2 equals, we can't use these two pieces, right? Because we don't know what y is. But we know square root of 2 and 1, right? So x over square root of 2, that's this piece over this piece, equals square root of 2 over 1. So you use that basic 45, 45, 90 as a similar triangle to set up a proportion. Okay, so that's why it's important that you memorize those values for those two special right triangles. Okay, and it's only those two that you're going to have to worry about. And these two special right triangles are going to carry you into Math 3 and also into pre-calc. Okay, because they start doing a lot with those. All right? And so now we just cross multiply. So x times 1 is x. What's the square root of 2 times the square root of 2? It's just 2. How come? So when you multiply a radical times a radical, you just multiply what's inside and put them underneath the same radical, right? So square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay? So x is equal to 2. They basically give you a triangle that's a scaled version of the basic one. And then you have to find the missing piece. So you have to use the basic 45, 45, 90 to set up your proportion. Same thing with the 30, 60, 90. Okay? And so eventually you'll get to where you don't need to redraw a whole new triangle. You can just I put the values in, I put a little circle around it, and I know that's the corresponding piece to it. Okay? So let's move on to number 2. I want you to try number 2. Oh, we didn't finish number 1. I'm sorry. We only found x. I'm sorry. Let's finish this. Now let's find y. We didn't finish number 1. I didn't follow all the directions. We need to find y also. Okay? So when I set up my proportion, I'm going to say y over what? 1. Because y, its corresponding part is 1. Equals what over what? You don't want to use the value you just found. So you don't want to use x. Because if that's wrong, then you're going to mess up y also. So equals square root of 2 over 1. This is the piece that we know for sure is correct. So that you're going to do is that piece over that piece. Okay? And so now we just cross multiply. So y equals square root of 2. And leave it in exact form. Don't give me a decimal answer. That's why in the instructions it says leave your answers as radicals in simplest form. If it was, say, square root of 12, you would need to simplify that. Okay? Square root of 12 is equal to 2 square roots of 3. So you would need to simplify that. Any questions? So all we're doing is we're setting up a similar right triangle and then doing our proportions with corresponding parts. Okay? I want you guys to try number 2. Solve for m, solve for n. Okay, so this is our 2 pieces of information that we know for sure. Our corresponding parts that we have all the information for. Okay? We have to solve for m, and then we have to solve for n, or vice versa. Okay? I'll do m first. So which part corresponds with m? M over, let's square root of 2 equals 10 over 1. Okay? And then we would just cross multiply. So m times 1 is just m equals. Now 10 times the square root of 2, is that square root of 20? No. 10 is not underneath the radical, so you can't multiply it to the 2. That's also when that is underneath the radical. Okay? If they both were square roots, then you would. So you just leave this 10 times the square root of 2, or 10 square roots of 2. You just leave it like that. Okay? So that's m. Now n. What part corresponds with n? N over what? N over 1 equals the two parts that we know, 10 over 1. So when you cross multiply, n equals 10. But like I said, the legs are the same for 45, 45, 90. So the legs are going to be the same here also. Notice that it's 1, 1, square root of 2. That's the same thing as 1 times the square root of 2, right? Anything you can multiply times 1, right? Okay. So look at this. This was 10. What did n end up being? 10. What did m end up being? 10 square root of 2. 10, 10, 10 square root of 2. What if your legs were 5? Then it would be, both my legs would be 5. What would my hypotenuse be? 5 square roots of 2. What if both of my legs were 7? What would my hypotenuse be? 7 square roots of 2. Okay? Okay, so you'll start to recognize these patterns and it'll be easier for you to fill in. Let's go to number 3, because number 3 has some radicals that we need to practice. Practice calculating with them. Okay? Same thing. What type of triangle is this? 45, 45, 90. Correct? Okay? 45, 45, 90. So I'm going to compare it to another, the basic 45, 45, 90. Okay? Where it's 1, 1, and square root of 2. Correct? Okay? So let's solve for x. So it's x over what? X over square root of 2, because here's my corresponding part, this one and this one. Hypotenuse over hypotenuse equals, I can't do y over 1 because then that'll give me two unknown variables, right? So equals 7 square roots of 2 over 2 over 1. Okay, now that looks complicated, right? Because you have a fraction over a fraction. There is something you can do to get rid of that denominator for the entire triangle, okay? And I'm telling you this, it's going to seem complicated at first, but when you get to something like this, when you start cross-multiplying, you have 7 square root of 2 over 2 times the square root of 2 equals x. If you're comfortable calculating that, fine, okay? But this is something that you can do so that when you set up your proportions, none of these are fractions, okay? It's easier if none of your sides are fractions. So if I want to get rid of a fraction, if I want to take something that's a fraction and make it not a fraction, what do? Multiply by the denominator, right? If you multiply by the denominator, then it's not a fraction anymore, right? So if I take this and I multiply it by 2, then that goes away, right? But if you do it to one of the sides, do it to all of the sides. You have to do it to all the sides. If you double the size of one of the sides, you have to double all of it. And multiplying by 2 is just doubling it, right? So that you're not dealing with fraction over fraction, because I know you guys hate fractions. If you have a problem where it's a fraction, multiply by the denominator, but you have to multiply all 3 sides by that denominator so that it stays scaled the same. So multiply this by 2, multiply that by 2, and multiply that by 2. So now when you set up your proportion, it'll be a lot nicer to look at. Okay? It'll be a lot nicer to look at. So again, now let's solve for x and let's write that proportion. So we have 2x over square root of 2, right? Equals 7 square roots of 2 over 1. Well, that's a much nicer proportion to look at. Because then you don't have a fraction over a fraction. It's not wrong to do it the first way, but it just increases your likelihood of making a careless mistake. Okay? So if we get rid of those fractions to begin with, then we set up our proportion and cross multiply. Does everybody understand? Yeah? I'll wake up. Okay, so now when we cross multiply, we have 2x times 1, which is 2x, equals 7 square root of 2 times the square root of 2. Okay? Well, you told me in the last problem, what's the square root of 2 times the square root of 2? It's the square root of 2, which is just, the square root of 4, which is just 2. So this is 2x equals 7 times 2, because this times that is actually just 2. Okay? So now we just have 2x equals 14. Divide both sides by 2, and x equals 7. So if I don't do this, even I get confused. I get confused when I set up that proportion. Okay? So do yourself a favor. If one of these problems has a fraction in it, multiply all 3 sides by that denominator to get rid of that fraction. Then set up your proportion. Now, do I need to set up a whole other proportion to solve for y? This is a 45, 45, 90. So what do we know about the legs? They're the same. So if this leg is 7 square roots of 2 over 2, then what's this leg? 7 square roots of 2 over 2. Okay, don't do more work for yourself than necessary. If it's a 45, 45, 90, if you know one of the legs, you automatically know the other leg. So we know that y is 7 square roots of 2 over 2. So you don't need to set up a whole nother proportion. The legs are the same in a 45, 45, 90, because the 45-degree angle and the 45-degree angle are the same. So the sides opposite them are the same. Any questions? Okay. Let's move on to number 7. Let's do a 30, 60, 90. But it's done exactly the same way. Except with 30, 60, 90, your legs aren't the same. So let's All right. Now we know this is a 30, 60, 90 because they tell us one of the angles is 30, which means the other one has to be 60. Okay? So if this one's 30, this one's 60. Did I? Oh, sorry. Number 7. You're absolutely right. Okay. So that's okay. We'll go back and do it if we need to. All right. So we have a 30, 60, 90. So we need to compare it to the basic 30, 60, 90 so we know how to set those proportions up. Okay? Now, 30, 60, 90 is 1, 2, square root of 3. Where does the 2 go? Where does the 2 go in a basic 30, 60, 90? The hypotenuse. The hypotenuse. Where does the 1 go? Across from the 30 or 60? 30, the smallest one. Okay? And the last one is square root of 3. That's how the process in my brain does it. I place the 2 first because I know it's the hypotenuse. And then the 1 goes opposite the 30-degree angle. It's the smallest one. And square root of 3 goes across the 60. Okay? Now we set up our proportions. The 2 corresponding pieces that we know in these 2 are both of the hypotenuse, right? Both of the hypotenuse. We know 8 and 2. So that's what we're going to use to set up those proportions. So let's solve for A. So it's A over what? Square root of 3 equals what over what? 8 over 2. Okay, so when we cross multiply, A times 2 is 2A equals 8 times the square root of 3. That's just 8 square roots of 3. And then to solve for A, we have to divide both sides by what? 2. If I divide both sides by 2, is that 3 affected by that 2? No, it's protected underneath the radical. It does not change. Okay? But the 8 and the 2, you can actually divide those. Sometimes you just have to reduce them. Sometimes they divide evenly. But 8 divided by 2 is 4. So this is the same thing as 4 square roots of 3. Okay? And it's the same thing in these problems. If they would have given me a fraction for this, I would have multiplied all 3 sides by the denominator to eliminate that fraction before I set up my proportion. Okay? Now we solve for B. B over what? B over 1, because these are corresponding parts, equals 8 over 2, the pair that we know. So when we cross multiply, 2B equals 8, divide by 2, and B equals 4. Any questions? All right, let's look at number 10. Now, what type of triangle is it? 30, 60, 90. Good. It's 30, 60, 90. Okay? So this is 60, this is 30. Now, instead of drawing a whole nother triangle, I'm going to do what I started to do in that very first problem. I'm just going to write in my corresponding pieces and put a little circle around it so that I know what piece goes with what. Okay? So, 30, 60, 90 is 1, 2, square root of 3. Where does the 2 go? Hypotenuse. So, this would go here. I'm just not redrawing the second triangle. Right? Where does 1 go? Across from the 30. And then this would be the square root of 3. Right? So if I redrew that triangle, those would be my measurements. Everybody with me? Okay. If you're just comfortable just drawing a second triangle and doing that, then please, by all means, do that. Don't do this if it confuses you. Okay, so now we're gonna set up our proportions. All right. So we have to solve for m and we have to solve for n. So I will go in alphabetical order, and I'll start with m. So it's m over what? 2 equals, well, I'm not going to do this one because I don't know what n is, right? So when you do it like this, the reason why I put a circle around it, so remember, you have to keep them in the right order. So it's the unknown triangle over the basic one, okay? So m over 2 equals 4 over square root of 3. Everybody with me? Okay? And so now we cross multiply. So m times the square root of 3 is just the square root of 3 times m. Don't put that m underneath that radical. It's not there to begin with. You can't put it underneath there for just no reason. It's the square root of 3 times m equals 2 times 4, which is 8. Okay? If that was just 3m, we would divide both sides by 3. Correct? Well, the process doesn't change. We're going to divide both sides by the square root of 3. Now, if we were allowed to give our answer in decimal form, then we would do that, okay? But we're not. They want exact form. You cannot have a radical in the denominator, okay? So think back. What do we do to get rid of that square root in the denominator? If we take it and multiply it by itself, square root of 3 times the square root of 3 is just 3, correct? So multiply it times itself. But if you do it on the bottom, you also have to do it on the top so that that fraction, the value of that fraction doesn't change, okay? So if we multiply the bottom by the square root of 3, we have to multiply the top by the square root of 3 also, because now all I've ultimately done is taken this and multiplied it by 1. Anything over itself is just 1, right? So now, on the top, you leave it 8 square roots of 3, but the square root of 3 times the square root of 3 is just 3. So this is an acceptable answer. It is mathematically equivalent to that, but you're not allowed to put your answer with the radical in the denominator. Okay? Can't have an irrational number in the denominator. So we made it rational. We forced it to be rational. So m equals 8 square roots of 3 over 3. So I wanted to work this problem with you guys so that you would remember how to get rid of a square root in the denominator. You just multiply times itself. But if you do it on the bottom, you have to do it on top also. Okay? Now, solving for n. Let's solve for n. N over what? 1. N over 1 equals 4 over square root of 3. So aren't we going to end up having to do the same thing again? So when we cross multiply, we get square root of 3 times n equals 4. So now we divide both sides by what? Okay. So n equals 4 over the square root of 3. How do I simplify that? Or how do I rationalize that? It's a rational rate. Multiply the bottom by itself, by the square root of 3, and then I also have to do them on top. So we'll multiply this, do that on top and bottom. So now you end up with 4 square roots of 3 over what? 3. So n is 4 square roots of 3 over 3. We have two different triangles, two different special right triangles. The top triangle is what kind? 45, 45, 90. And the bottom is 45, 45, 90. So when we're solving for x, I don't have enough information here to be able to set up a proportion directly with this bottom triangle. Okay? I don't have enough information. So I have to use this, find the measurement of this segment that connects the two triangles. Find the measurement of the segment that connects the two triangles. Okay? And that's always going to be the case. When you have two triangles together, you're going to do this in Math 3. You want to find the measurement of the piece that connects them both together. That's going to be your link going from one triangle to the next. Okay? And so I'm going to call this, we'll call that y. Because in order for me to set up a proportion with this bottom triangle, I need at least one side. I need one of those sides so that I have a known corresponding pair to the basic ones. Okay? So in this case, we're not going to find x first, we're going to find y first. So you're going to pretend like that bottom triangle doesn't exist. And we're just going to look at this. Okay? Now, if this is our 45, 45, 90, which it is, my legs, so let's compare it to this. Okay, this is the 45, 45, 90. It's 1, 1, square root of 2, right? That's the pattern. So 1, 1, square root of 2. Okay, for right now, we're pretending like this doesn't exist. So let's do this. See, we'll pretend like it's just that. Okay? And so that was 1. So we're going to solve for this piece right here. And once I know that, then I can look at the bottom triangle and set it up and solve for x. So we have y over what? Y over what? 1 equals what? 5 over square root of 2. Okay? So we have to cross multiply. So square root of 2 times y equals 5. Now what? Divide both sides by. We have to fix this. Right? We have to fix this. So we're going to multiply the top and bottom by. So it's 5 square roots of 2 over 2. Okay? So now, let's look at what we actually have now. Okay? Now this is 5 square roots of 2 over 2. Now you're going to look at just this bottom triangle to find this missing piece. This is a two-step process. Okay? Now, remember what I said, you don't want to set up a proportion when one of your sides is a fraction, right? You don't want to set up a proportion when one of your sides is a fraction. So, how do I easily make this not a fraction? Multiply by 2, right? 5 square roots of 2 over 2. To make that not a fraction, I just multiply it by 2. So when I do by 2, those cancel. But you have to do all 3 of the sides by 2. It's 2 separate problems. Listen, if it makes it easier, draw them as two separate triangles. Okay? It looks complicated because the two triangles are connected. But literally redraw them as two separate triangles if you want. Okay? This problem is combining everything that we've done. It's combining getting rid of the square root of the denominator. It's getting rid of the fractions before you set up your proportion. Okay? Those by themselves are simple processes. Yes, ma'am?
That's what y equals 5.
Yes. Yes. That's what y equals. If you get confused, stop me. I don't want anyone to get confused. This process is not difficult, it's just tedious. Okay? So what we did was we looked at the first triangle to find this segment. This is this segment, all right? This segment for the bottom triangle is the hypotenuse for that bottom triangle. Yes, ma'am. Right here?
No. Besides eggs.
Oh, okay. Because when we found this, it was 5 square root of 2 over 2, right? Before I set up my proportion with this, I got rid of this denominator.
Oh, so you multiply.
I multiplied it by 2. But if I do that on one of the sides of the triangle, I have to do it on all of them. Now, I'm not worried about the top triangle anymore. I'm done with that. Okay? All right? So now, we're going to take this 45, 45, 90 and compare it to the basic 45, 45, 90. So we can set up our proportion to solve for x. All right, see, if we knew what this other leg was, we wouldn't even have to worry about setting a proportion because 45, 45, 90, the legs are the same, but we don't. Okay? So, in a 45, 45, 90, both of the legs are 1, 1, and then the hypotenuse is 32, right? Okay. So we would say 2x over what? 1 equals, this is my hypotenuse, 5 square root of 2 over square root of 2. Yes.
Why did you put regular line under the triangle? On the other triangle?
Oh, because I had to put that screen up to cover it. I'm sorry. I put the screen up to cover it so that you guys aren't looking at the bottom. No. Okay, so does everybody see where this proportion came from? Okay. Now, I can do something before I even cross multiply. What can I do? Cancel the square root of 2. Cancel the square root of 2's, right? Anything divided by itself is just 1, right? So now when I cross multiply, my radicals are gone. So that's 2x times 1, which is just 2x. And then it's 1 times 5, which is just 5. So x equals 5 halves.